Two sets of parametric equations, x equals t, y equals t squared plus 1, and x equals 3t, y equals 9t squared plus 1, correspond to the same rectangular equation. True or false? So first let's find the rectangular equation of the parametric equations x equals t and y equals t squared plus 1. So all you have to do is solve for t on both sides and then set those equations equal to each other. So if you solve for t on y equals t squared plus 1, you get t equals the square root of y minus 1. And then you set that equal to x, and then after solving that equation, doing x equals square root of y minus 1 equals x squared equals y minus 1, and then that is equal to x squared plus 1 equals y, which if you rearrange it will be y equals x squared plus 1. Now knowing that rectangular equation, let's see if the other set of parametric equations will result in the same rectangular equation. So x equals 3t and y equals 9t squared plus 1. For x equals 3t, t equals x over 3, and then for the y equation, t will equal the square root of y minus 1 over 9. Now, knowing the t values of those, you do the same thing as you did before and set those equations equal to each other. So x over 3 equals the square root of y minus 1 over 9. And then you solve this down to a rectangular equation, and you can get x over 3 squared equals y minus 1 over 9. And then since there are 9's on both sides, those can cancel out. You get x squared equals y minus 1. So x squared plus 1 equals y, and rearranged is y equals x squared plus 1, which, as you can see, is the same thing as before. So true or false? I think it's true. Definitely. Both parametric equations will result in the same rectangular equation. True. The graph of the parametric equations x equals t cubed and y equals t minus 1 is shown below. Would the graph change for the equations x equals negative t cubed and y equals negative t minus 1? If so, how would it change? And here's our beautiful graph. So this problem is very similar to what we did before. One way we can do it is just solving for both rectangular equations and seeing if they're equal to each other. Another way is just putting your calculator into graphing mode and then seeing if both of those equations will line up. But here I'm going to show you how to do it in finding the rectangular equation. So the first two sets of parametric equations are x equals t cubed and y equals t minus 1. We solve for t in both of those equations. So for the x, you get t equals the cubed root of x, and for y, you get t equals y plus 1. Set those equations equal to each other. The cubed root of x equals y plus 1, so x equals y cubed plus 1. Rearranged a little bit, y cubed equals x minus 1. And then for the second set of parametric equations, you have x equals negative t cubed and y equals negative t minus 1. T for the x equation will be equal to the negative cubed root of x, and t will equal for the y equation y plus 1. Set those equations equal to each other, and you get the negative cubed root of x equals negative y minus 1. And then getting rid of those negatives, you get the cubed root of x equals y plus 1, and then x equals y cubed plus 1, and then finally you rearranged it, y cubed equals x minus 1, which is equal to the other rectangular equation for the other set of parametric equations. So of course it would not change. So for question 68a, you have the equations x equals 6 cosine theta and y equals 6 sine theta, where theta is less than or equal to 6, but greater than or equal to 0. So here's a little depiction of what that might look like. And For A, I want you to describe the orientation of the curve. Okay, so turn on your calculator and press mode, then go down to parametric. We're going to graph these to see which orientation it is. So for x, you're going to type 6 cosine t, and for y, I'll type 6 sine t. However, you have restraints on theta, so go to your window and change your t max to 6, then graph. As you can see, your curve is going to be going from right to left, and there is that little gap due to the theta restraint. So the orientation of your curve is counterclockwise. 68b asks you, determine a range of theta that gives you the graph of a circle. So normally a circle will have a theta range of 2 pi, however, ours has a restraint of 0 to 6. So in radians, our range of theta will be from 0 to 6. However, if you want to visualize it better with degrees, we can always convert it by multiplying the 6 times 180 over pi, getting approximately 343.77 degrees. And you can see this on the circle where there's that gap there. 68c. Write a set of parametric equations representing the curve so that the curve traces from the opposite direction. X equals 6 cosine theta and y equals 6 sine theta. So, as you can see, the curve traces in a counterclockwise direction. So in order to make these set of parametric equations write the curve in the opposite direction, all you have to do is make your theta negative. So your new set of equations are x equals 6 cosine negative theta and y equals 6 sine negative theta. How does the original curve change when cosine and sine are changed? We have x equals 6 cosine theta and y equals 6 sine theta. So one way to do this is just flip your cosine and sine in your graphing calculator and then graphing it. However, another way is just to find the rectangular form and seeing if there are any changes in your equation. Use the steps that I previously described in former problems to figure out the rectangular equation. Continue watching to see the answer.